Welcome to Unit 7, Chem 1, where we take a look at chemical formulas and how to write names of chemicals based on their formulas. Let's get started in 7.1 with naming covalently bonded substances. Before we get to covalent, let's take a little time to review how we name ionically bonded things. Remember that ionically bonded substances have a positive cation and a negative anion. This is often between a metal and a nonmetal, but it could also include polyatomic ions. These charges occur because of atoms losing and gaining valence electrons. But in the case of a covalent bond, electrons are not lost or gained. Nonmetals typically are trying to gain electrons to acquire a stable octet. But if those nonmetal atoms are around other nonmetal atoms that are also trying to gain, the only way to make that stable octet occur would be for them to share some of their valence electrons, or make certain valence electrons common to both of them. Typically, when we say sharing electrons, covalent bonding is what should pop into your brain. So when two nonmetals share valence electrons, we typically form a covalent bond, and we call this a molecule. Any pair of electrons that are not shared would be considered a lone pair, because they just belong to the one atom. You can see down here in the bottom we have carbon and hydrogen. Those are both nonmetals. And you can see how this has been color-coded, where the blue valence electrons belong to carbon, because carbon has 4 valence electrons, and the red valence electrons belong to the hydrogen. Each hydrogen has 1 valence electron, and it's sharing with carbon. And so now you can see that not only does carbon have a stable octet, but each hydrogen is stable because it requires 2 electrons to fill that first energy level. So the covalent naming system, I believe, is a little easier than the ionic naming system, because all you're going to do is use prefixes to tell how many of each atom is in the formula. The prefixes we use are down here at the bottom. We have everything from mono to octa to deca. Some of those might be familiar to you. The other thing that we do that's similar to ionically bonded things, in binary compounds, which means we only have 2 atoms or 2 elements present, the second element gets an IDE ending. So you may have heard carbon dioxide. That's a covalently bonded substance, and it's not carbon dioxygen. We've changed the ending to IDE. The other thing that's important to know is that anytime we have one of the first atom, we do not put the prefix mono on. We just leave it as the name of that atom. But all other times we put a prefix on either the first or the second atom. Let's do some examples, and I think you'll get the hang of this. So here we have NO. We have 1 nitrogen and 1 oxygen. So since we have 1 nitrogen and it's the first atom, we would just write the word nitrogen, the name. With the second atom, oxygen, we only have 1, but in this case we are going to use the prefix, making this monoxide. Notice we've used the prefix mono, and we've changed the ending to IDE, making this nitrogen monoxide. Let's try the next one. This is the first atom, phosphorus. We do not put the prefix mono on the first atom, so this would just be phosphorus. And then you can see we have 5 chlorines. The prefix for 5 is penta, and then we would change the ending to IDE, pentachloride. Here's another one. This time we have 2 nitrogens. We do use all the other prefixes. We just don't use mono on the first atom. So this would be dinitrogen trioxide, because the prefix for 3 is tri. There are some other common names that we want you to know. For instance, carbon tetrahydride, the common name is methane. This is a flammable gas, and you'll see it in a lot of chemical reactions. Another compound that you'll see a lot in chemical reactions is ammonia, which is NH3. It's not the polyatomic ammonium, which is NH4 plus 1. It's ammonia, NH3. And yes, that's a household cleaner that you may use in your home. Attached in your packet is this chart. It's a very helpful flow chart to help you keep the naming system separate. So at this point in time, we've covered how to name ionic substances, usually a metal and a nonmetal. And we've dealt with how we name the cation, and then we might give the charge of the cation if it has different charges, and then we name the anion and we put an IDE ending. Today we covered molecular or Covalent compounds, which are nonmetals only. We give the prefix, name the first element, prefix, name the second element, and we change the ending to IDE, like P2O5 down here, diphosphorus pentoxide. The next time we're together, we're going to talk about naming acids. But I would definitely keep this chart close as it helps you organize the 3 different naming systems that you're going to be responsible for. Spend some time working on the activity, naming ionic and covalent compounds. Let me know if you have questions. We will see you soon.